Light up an old celebration cigarette on this one. Mr. Gatekeeper here. What we have here is a very, very unique amplifier. I basically had what is now a good buddy of mine. He came to me with a little idea. And he had been doing some research and some homework and whatnot, trying to find a Motorola transistor that could possibly hang with 2879s. So, like I said, he did his homework. He found a transistor he felt was worth trying, which is a Motorola MRF421, which does cost a bit higher than the Toshiba at the present moment, but he got a quad match set from RF Parts and sent them on up here, and I did a little bit of homework myself, and I decided to go ahead and go with the highest gain MRF455 that pretty much is in existence, which is a double orange dot. That is the highest gain value 455. So I went ahead with a 455 driving these four Motorola MRF421s, which is some pretty unique transistors, and I'm pretty happy with the outcome, how everything turned out. Now, do keep in mind, I have always noticed this, that Motorola seem to not do as much peak watts, PEP watts, as Toshibas do. And a lot of people wonder, you know, what's up with that, but about the only thing I possibly could think of is possibly Motorola's might be a little cleaner transistors, but you know, that's food for thought. So another neat thing that we decided to do to this build, it has a built-in WiMOte, a built-in wireless remote control to turn this bad boy on and off. WiMOte version 2.0. The programming control is right here, and there's your indicator light for it. And I went ahead and unprogrammed the WiMOte, just like he was getting it for his first time in the mail. So I did have this remote right here programmed to it, but I went ahead and erased the memory, which all this can be done from the control back here. This is a smart button. So I'm actually going to program this remote control and this one right here on the spot before we even get started. So that's the neat thing about version 2.0. Alright, I'm going to reach over here and turn over the unregulated supply. Alright, what we're going to do now is we're going to program the remote on how we want it to function. We want A on, B off. Hold down the smart button. We're going to wait for it to blink 3 times. 1, 2, 3. Alright, now we're going to program the remote. There it is. So you can turn this amplifier on and off with this remote without having to plug anything back here. And if he ever still wants to use a wire with a remote, he can do that as well. Alright, just turn it off. Just for the fun of it, to demonstrate multiple usage, we'll go ahead and program this remote as well. As you see, it does not work. Okay. So the light comes on, hold it down. There you go. Two remotes. You can program up to, I believe it's 20 remotes to this one unit in here. So he can have him a remote and a backup remote. Alright. So let's go ahead and demonstrate what this bad boy is doing. We're first going to drive 4 watts RMS from the radio We're on the unregulated 100 amp supply, and you're about to see that these transistors are operating more efficient than Toshiba 2879s, and you will see this here in just a moment on how much output I'm getting and how much amperage it's pulling to give that output. 1000 watt slug, RMS. Oh yeah. Oh yeah. Now take a look at the amperage. That's about 380 watts RMS. Oh yeah. 17 volts. A regular one driving 4, which you can take a look at the video I did last, doing 380 watts RMS like that is going to be pulling a lot more amperage than that is. So that's very neat. It is making more wattage with less amps. That's called efficiency right there. Here's your input reflect. Hello. Beautiful input reflect. Hello. Yeah. Sit there and roll that variable down to a little bit under 100 watt dead key. Oh yeah. Beautiful. Beautiful. Take a look at the peak real quick. I usually don't use this slug for peak, but oh yeah. It usually cuts off right there about 600 watts. Something's up with the actual meter itself, not the slug. That's why I use a different slug for PEP, which we will do after we hook up the hot radio. Because right now it's really doing about 680, 700 watts PEP. Now, we're going to hook up and double our input power from 8 watts RMS. From 4 watts RMS to 8 watts. Okay. I'm going to turn that variable back up just a little. Okay. 1000 watt slug RMS. That is correct. Go right there at 550 watts RMS. Now take a look at the voltage drop. Go. We about damn tricked the breaker there. Let's turn that back on. All right. Go 15.5 volts. Yeah, the breaker for the radio. That's fine. Yeah, I turned it back on. Oh, you turned that on and that? Okay. Alright, anyway, sorry about that, y'all. Go. Beautiful. Beautiful, beautiful. Very happy with the amount of output this thing is doing. We're going to put the 2500 watt slug in now and take a look at the actual PEP wattage of it. Okay. Alright, PEP's on. Go right there about 1100 watts. Alrighty, well, my battery died on me while I was doing the video just then, and I quickly figured out. See, that's one thing I'm gonna do. I'm never gonna try to make something look like it's something that it ain't, and if I do, it's by accident. We thought that the breaker to the switch down here, well, not that one, there's one over there that my radio's hooked up to. It's a strip that's got a breaker built into it. I had it throw about a week or a week and a half ago, and that's what I thought that happened, that a breaker had thrown because I wasn't getting no audio. I wasn't seeing the unregulated supply dropping, so that's what I automatically thought. And then unconsciously, I flipped this switch on the amp and turned it on. You know, when you're doing a video and something goes wrong, you kind of freak out for a second. But I figured out what happened. The WiMOte got fried. And this is it right here. I quickly figured out what happened. And right when that was happening, my buddy was telling me he just started the dryer over here, and that a fuse had, a breaker in the bathroom had went out too. So it was a bunch of I thought a breaker, basically I thought a breaker had went, but that's not what happened. What happened actually was I was on with the WiMOte, so the WiMOte had turned on this box and the switch was off. Okay. And I learned something new I didn't know about these units, because up to now I have made these units mostly for people using them in a mobile, you know, on regular battery voltage. But these are sensitive to voltage, so with it sitting on that 22 volt float over there, it fried the WiMOte. Took out the diode right there, and I replaced the diode on it. This diode right here. I replaced that diode on it, and the LED was getting power at that point, but I think it took out one of the modules in there. So now I know if anybody ever wants a WiMOte built into their box and they want to run it on a base or unregulated supply, I will need to take my precautions and using some internal regulation to keep this to keep the WiMOte at pretty much a steady 13 to 14 volts or so. So anyway, I learned something new during that video. I took out a module, a WiMOte module. Basically, you know, these modules, I do about 3 or 4 modifications to them before I use them for what I'm doing them for. So it wasn't that big of a deal. We got another one in there and back up and rolling. Some people would probably edit that out, but you know, I leave stuff like that in just to show everybody I'm a natural guy that makes mistakes, and I learn things during videos, and I fry things sometimes, Captain Picker. Hey, if you don't fry nothing, how you gonna learn? You know what I'm saying? But it's all good, man. Just that high voltage sitting on that WiMOte module, because basically that module is getting power from the power source, and since my buddy's not going to be running this box on a unregulated supply, I didn't do any regulation to it. I just replaced the module, and I've got it hooked up to the regulated on 14.4 right now, but I'm not going to be keying it up no more. It'd turn that supply off. But yeah, I was just doing that just to show you it's up and rolling, and that's what happened. So it's all good. Now I know the old WiMOte can't handle that high voltage on the float there. So we live and we learn. So anyway, it's time to pop the old 10s off this Captain Picker, man. Really, really, really neat amp. I'm flabbergasted with how well it turned out. And I know my buddy's very happy too right now, because it looks like they not only performed as Toshiba's would, they performed like a set of hot Toshibas, like real strong gain Toshibas. And if I could have kept that at a steady 16.5 volts, oh, this thing can do 600 bird all day long. So there she be there. Single 1446. Let me take a breather here and calm down. All right. A steady Motorola double orange dot, highest HFE gain in the book. I've been saving this for a special occasion. A single MRF455 driving 4 Motorola MRF421s. Not only to add that, all metal clads. That was a request by Mr. Ramon. A lot of times when I get these videos done, I'm actually starting the video there. I always forget the person's call. I'm sitting here searching my mind right now. I don't talk to him out in DX land. We talk over the phone, so I can't quite remember. I just know him by his name. But there you go, bud. I appreciate your patience, man. I know you've been waiting for a second for this one. This whole thing had to be absolutely individually tuned. There was trimmers at every tuning section. A trimmer here, a trimmer here, a trimmer here, and a trimmer back here. These are all the trimmers that was used to tune this thing out, man. And that's the way you got to do it when you're dealing with some transistors that you've never used before and you have no idea what the tune's going to be. So we got this bad boy individually tuned, man. Had to put in an order of about $250, $300 worth of metal clads just to get this thing tuned. I didn't have to spend that much, but you know, I individually match each capacitor. Meaning, these, for example, these 120s right here on the strip here. You got one here, one there, one there, one there, 4 total, 1 per transistor. These are exactly matched together at 120 picofarad. To do that, you can't just go buy 4 of them. You might have to get you 20, 25, 30 of them. So I had to do some re-upping when I did this box here. So, but it turned out great, man. I'm very happy the way it turned out. There's your new WiMOte module. And now I know, just don't be running no unregulated supply. I probably wouldn't put no more than 16 volts or so when you're using the WiMOte. Because I've got at least 40 to 50 WiMOtes out there in operation right now. And I would say at least 80 to 90% of them are being used in mobile use. I do have a few people that's using them on the base, but I guess I haven't heard any problems out of them, so I guess most of those people are using them on regulated supplies. So, but now I know if I know somebody could possibly use it on an unregulated supply or be doing any kind of volting or anything like that, I'll just throw some a big regulator in there and let that thing run off a regulator. And you can go ahead and, like I said, still run a wired remote in the future if you want to, if you feel the need to. I left that in there, and turned out great, man. Great. Needed some input pad, man. This thing was dead keying almost 700 watts at one point in time. I tell you what, man, it turned out great. I'm real happy with it. Very happy with it. Well, there she is, man. These transistors are, you know, not exactly cost effective. They cost around $70, $75 a piece. But he wanted to see if these things could do what Toshiba's doing. As you see, they do. Asked me a little better. I know I just made a video before this one of a 5 transistor amp doing around the same amount of power. But if you watch it, that's the highest output 5 transistor amp I've done yet. So they normally don't do that much. So this thing really shocked me, man. Ranking it in 500 and I believe 80 RMS, peaking 1100 watts, which is real nice, because it was hard to get a kilowatt out of it at first until I did a couple of more tests, a little bit more arranging around, playing around with the wraps, the capacitance, all that good stuff, and I was finally able to bust over a kilowatt with it. So it took a little work. Got the output cap right there, running with that blue and white theme. All right, let me quit boring y'all. Get on out of here. We call this the MOTOBOX. The breakdown voltage on these puppies are 20 volts. 2879s are 18. Plate dissipation 290 watts. 290 watts per transistor is the power dissipation. Excuse me, not plate dissipation. Toshibas are 250. So there you go. If this is something you might like, give me a shout. 73s, everybody out there, God bless. From out here around the northeast end of Georgia. We're going to go ahead and hit the sack, y'all. Put on some X-Files. We're getting called up about the working my way up to start the new season. Hell, I ain't never watched none of it till about a week or so ago. 73rds, much love, y'all. To the next. Everybody out there, continue being patient with me. We doing everything we can. Me and Mr. 073. I got to give him a shout out, man. I about forgot. Mr. 073 has his hand in this build as well, man. He helped me a little bit when we were starting off, man. Did a good bit of work in this box. So, appreciate you, Mr. 073, for the extra help getting this bad boy finished up there, man, where we can get it out the door. All right, 73s, y'all. We gone. Bye. Have a good one.